Hello, everybody, and welcome to the Strength of Materials Lab. This is a lab where we look at how materials respond to the forces that we apply to them, how they deform and how they break. And also we examine how the application of plastic deformation and heat to the materials changes their properties. And so as a result of that, there are some intrinsic hazards that are associated with this lab. And what I'd like to do today is to introduce you to those hazards and how you can deal with them best. This lab is not a tremendously hazardous lab to begin with, but there are some dangers associated with it, which I'll explain to you today. And as with any lab or engineering system, the knowledge and behavior of the operators is crucial in either minimizing or increasing the hazards associated with the equipment. So what I'm going to talk to you about today are some of the things that are in this lab which could potentially injure you. We are deforming materials, and some of the materials are quite strong. If you are going to want to permanently change the shape of a large sample of steel, you have to apply thousands of pounds of force to that. So that necessarily means that there is a potential for a crush injury. If you put a body part in the point of operation, as it's called in machine injuries, where the action is, where the specimen is getting compressed or pulled on, if there's a body part in there, then you can injure that body part because of the huge forces. So that's one hazard. The other hazard is that we are taking these specimens to fracture. And some specimens and some materials, when they fracture in a relatively benign way. Those steel specimens, when they only break into two parts, and the edges of those two parts are not all that sharp. So it's pretty hard to injure yourself with a broken steel specimen. But we also do fracture of glass. And this is the glass specimen that we're going to be chopping into short 6-inch pieces and doing 3-point bending on. And when glass breaks, it breaks into a lot of shards. The edges of the specimen are very sharp and the shards are sharp. And so you have multiple hazards there. Potentially you can have a flying piece of glass that could hit you in the eye, which we want to guard against. But also just in handling the specimen itself and all of the shards that result after it's broken, you want to make sure that you don't cut your fingers. So there's a laceration hazard associated with that. And then the final hazard in the lab has to do with heat. We're going to be heating our metals often to hundreds or 1,000 degrees Celsius, very, very hot. And obviously that is the potential situation where you can burn yourself, which we're going to guard against. Okay, so let's start by talking about general best practices in terms of behavior in the lab. This is a shared facility with a lot of machinery in it, some of which is intended for regular standard experiments that we do in this lab, and some of it is research equipment. And as a general rule, you should not be touching any piece of equipment that you have not been trained for and authorized on. And you should not be using any test materials that you have not notified your instructor about, and your instructor hasn't examined it and talked to you about the potential hazards that that material poses. So let me just talk to you about what I mean by other pieces of equipment that you're not authorized on. There's many hazards associated with the equipment that are in this room, which are not part of our standard experiments, which if you just feel like fooling around with something, you can disturb, first of all, you can disturb a piece of equipment that someone has a long-running experiment running on and ruin the effort of a professor or a student who has been setting something up for weeks or months. So that's not good citizenship. But the other part about it is that you can actually ruin the equipment itself or potentially injure yourself because you're messing with something that you don't know how to use. So please don't touch any piece of equipment other than the ones that you're authorized to use. The other part about it is using materials that you bring in yourself, which are not part of the lab. If your instructor doesn't know about those materials, then those materials can respond to the equipment in unexpected ways, ruining the equipment or potentially injuring you. Just as a Quick example, we have a rolling machine over here that's intended to roll brass specimens to examine how that changes their hardness. A few years ago, someone thought it would be cool to run a coin through the rolling machine. You see these machines in zoos or amusement parks where you run a penny through it and it flattens it out. They thought it would be cool to run a peso through it. That resulted in breaking the gears of a multi-thousand-dollar piece of machinery, and then the students couldn't use it for the rest of the semester. The other thing is that if you're doing that, it's going to require much larger forces to push that coin through than it would with a regular brass specimen, and it increases the chances that you're going to pull your finger into it and injure yourself. So please just stick with the equipment and the materials that are in the lab. If you want to do something for a project, get your instructor's authorization on that. Okay, let's talk about personal protective equipment and appropriate clothing and garb for this laboratory. There are several things that you need to do to ensure that you can do these experiments safely. One of them is to ensure that you have closed-toed boots. And the reason for that is that we have several experiments that use heavy weights. These are 1, 2, 3 pound weights, half-pound weights that we stack together, and these sometimes get stacked on the edge of a table and fall off. Sometimes people lose their grips on it. If this falls on your sandaled foot, you're going to be very sorry. Okay, so please make sure you have closed-toed boots or shoes when you do those experiments. The other thing is that you're going to want to have safety glasses on. As I mentioned earlier, there are not too many instances of flying objects. We don't have chemical splash hazards. We do heat treat our steel by taking a hot piece of steel and putting it in water. The water boils, so there's some steam that comes off of that. But really the purpose of these safety glasses is to prevent injury to your eye from fracture of brittle materials, right? So in this class, the standard lab that we have, the only brittle material that we test is glass. But for example, in student-designed experiments, you might be testing some other brittle material, a composite material or something like that. And so anytime you're doing a test where there's going to be a potential for fracture of a brittle material, it's critical to have these glasses on. Our machines that do the tensile testing of those kinds of materials also have plexiglass shields on them, so you're double protected. But as a general rule, you should always be wearing your glasses. And you should bring your own safety glasses. These are good to have. They're just a few dollars from a hardware store or lab supply store. If you don't have your own safety glasses, your instructor can provide you a loaner. But just make sure you don't try to do any experiment without safety glasses on. Okay, let's talk about crush injuries and how to avoid them. The main way that you can get crush injuries is to have your hand or a body part in between the parts of a piece of testing equipment that is moving. And several of our pieces of equipment have this hazard associated with them. The tensile testing and compression testing machines can do this. The torsion testing machine can do this, and the rolling machine can do this. And so there's several really important precautions. One important precaution is nobody should be touching the controls of a machine while another person is adjusting the specimen. There is no machine other than the rolling machine that is a two-person operation. You can set up your specimen in the process zone with no one else around. Once the specimen is completely set up and your hands are removed and your shields are in place, then you can operate the machine and deform it, so then there's no hazard associated with that. You absolutely do not want to have two people interacting with the machine at the same time, one in the hazardous zone and one on the controls. So this is our brass rolling mill, and it is really the only piece of machinery we have over here where while you're deforming the material, somebody else is going to be handling the specimen. Everything else, you set the specimen up, people step back and then you operate the machinery. But here we have little samples of brass here, which need to be fed through the rollers as the handle is being turned. And there are really two adjustments here. One of them is the separation of the rollers. The other one is the operation of the rollers that actually pulls the specimen in and squishes it down. So generally, one person is going to be feeding the brass into the backside of the roller while another person turns it over here. And so you want to be holding this specimen with a pair of pliers so that your actual fingers never get close to the pinch point of the rollers where the operation is occurring. The other thing to remember is that the lab manual and the video that I recorded for you to tell you how to do this experiment explain how much you want to reduce the separation between the rollers in each pass. If you reduce the separation between the rollers too much, then it's going to take a very large force to pull the specimen through the rollers. And that is hazardous, because what that means is someone is going to be really pushing hard on this to make it go, and it's going to feel out of control. And that's the situation where you can lose control of the specimen. So if you keep the adjustment to what is specified in the lab manual and in the video, it shouldn't take massive effort to turn this thing over and pull the specimen through, and that introduces more control into the experiment anyway. Okay, so let's talk about laceration hazards, really, and the only experiment in this lab that can potentially end up causing a cut on your fingers is the glass experiment. And that also is the experiment most likely to throw up shards of broken, sharp material. And so in this experiment, what you're going to be doing is you're going to be manufacturing about 6-inch long specimens of glass rod out of this larger, longer piece of material. So that's going to involve abrading and then fracturing the large rod into your specimens. So that, in the video that I've recorded showing you how to do that, you have to be very careful to keep your hands away from the location where it's going to be fractured, and you need to be wearing gloves when you do that. So if you're breaking this portion of the rod, you're going to be holding well away from that over here and over here with the glove-covered hands as you bend the rod in order to cause the fracture. What you don't want to do is have bare fingers near the location of the fracture. So that's one thing. The other thing that you want to do is, once the 6-inch rod has been placed on the 3-point bend apparatus, so I've got the grips out of the machine right now. These would normally go into that instron. And then the upper loading point comes down in contact with it, pushes down on it, and that causes the fracture of the specimen. And what that results in is broken pieces of glass. These are some of the fractured specimens that have been tested over here. And you can see not only is the edge sharp, but there are bits and pieces that stick out of the specimen. Over here, if you look closely, you'll see there's a little tab that comes off the specimen that is very sharp indeed, right? So the edges here are sharp, the tab is sharp, and the little pieces of glass that go all over the place are sharp too. So when you are cleaning up after your experiment, if you have a large piece of remnant of your specimen like this, you can safely pick it up in the middle as long as you don't go anywhere near the edges with your finger. But anything that is small enough so that you don't have a safe, polished, cylindrical middle to pick up with your fingers, really you should be cleaning it up with the brush and the dustpan. And these are always available right underneath the machine for you to do your cleanup with. Do not try to pick up those tiny little shards with your finger, because that is a hazard. Okay, the last hazard that we need to be careful about in this lab is a potential burn hazard that's associated with heat treating of our metallic specimens. So there's 2 heat treating furnaces over here, as you can see, And when we're heat treating brass to anneal it, we go up to maybe 400 degrees Celsius. When we're heat treating steel for the hardenability of steel experiment, we go up to 950, 1,000 degrees Celsius. So that's a very, very hot furnace. And the main precaution that we use to prevent injuries to ourselves is some personal protective equipment. We have some super heavy duty insulated gloves over here that you're going to be wearing whenever your hands are coming near hot metals. And then the actual handling of the specimens themselves are with these long tongs. So when you move the specimens either in or out of the furnace, what you're going to be doing is you're going to have your gloves on and you're going to be using tongs as a double security measure. And what I have over here is there's a furnace over here that is not on, but I have a steel specimen set up inside of it in just the location that you would have when you're doing the heat treatment of steel. So with your gloves on, you would grab the specimen, which would be glowing red at this point, with your tongs, lower it into the bucket over here where it's going to get quenched, and then let go. And just when you're transporting the hot specimen out of the furnace, just make sure that it's not over your feet. If the specimen falls into the bucket, there's a splash and your experiment is compromised. But if it falls onto your feet, then you're in really big trouble. So just be cautious about that. As long as you have your gloves and tongs while you're moving hot specimens, there should really be no trouble.